All right, you guys, so before you watch this video, you should have completed 10.1, area of parallelograms and triangles, and I guess that was it on that section, okay? So today we are going to talk about the area of trapezoids, rhombuses, and kites. Some of the things that we're going to talk about are going to be related to the stuff we did right before break. So like Pythagorean theorem, special right triangles. So if you need to go back and access those quick lessons, or you can honestly just Google a picture and you'll be able to hopefully remember those relationships. All right, so a couple things you need to remember about trapezoids first is that a trapezoid is a quadrilateral with exactly one pair of parallel sides. So the parallel sides are always your bases, regardless of how the trapezoid is like sitting. And then the height is the segment that's drawn from one base to the other, and that has to be perpendicular. It has to be a perpendicular segment. So for example, you could draw the height here, you could draw the height here, you could extend it out and draw your right angle here. It doesn't matter as long as it's from one base to the other and as long as it hits at that right angle. Okay. And so if we just look at this first example, oh, and I guess the formula is important too, right? And so the formula for the area of a trapezoid is always 1/2 times the height times the sum of the bases. Okay. All right. So the state of Nevada is actually a trapezoid. There's a little bit down here that's not part of it if you look at a true map, but in general it's a trapezoid. So you want to maybe turn your paper this way, and then these are going to be your two bases because those are the parallel sides. It doesn't matter which one you call like base 1 or base 2 for the formula purpose, because you're adding them together, so you can do that in any order. And then we can see this segment right here, that's the distance between the bases, so that's going to be your height. So luckily in this problem, there's no extra work we need to do, we just need to plug everything in. So you can kind of see some eraser marks too. I'm re-recording this video because I figured out how to get rid of the echo, and I'm trying not to waste paper or ink in my cartridge if I don't have to. All right, so 1/2 times the height, which is 309, times the sum of the bases, which would be 205 plus 511. So just to avoid making silly calculator mistakes, I would just start by adding those two together. So 1/2 times 309, 205 plus 511 is 716. And then after you do that, you can just multiply these three numbers together. So 1/2 times 309 times 716 is going to be 110,622. Okay. Now the units on area, remember, are always going to be units squared because we're multiplying, in this case, miles times miles. Whenever you multiply something by itself, you're squaring it. So your units should all be centimeters, inches, whatever they are, to the second power. All right, so in this next example, we're going to be going back to some special right triangles. And I wrote this stuff in pen the first time around, so it's already there. That'll just get filled in as we go. So we've got our trapezoid right here. These two sides are my bases. I'm given that this top base is 5 meters and that the bottom base is 7 meters. So to fill you in on what some of these numbers are, when I draw the height right here and here, I create a rectangle, right? Because that's going to be 5, and that's going to be 5 meters. And so if this whole base was given to me as 7, that means that this little section that I have left is going to be 2 meters. And so I will need that because right now I don't know what the height is. I only know the 2 bases. And so I am going to need to understand how to find the height. Well, when I draw the height in again, we created this rectangle and then this right triangle. And it'll always be a right triangle because the height has to be perpendicular. What's going to help us out in this one is that we know that this angle right here is 60 degrees. So that means that this is a 30, 60, 90 triangle. And so remember, the short side is always kind of what you need to figure out because the other 2 sides are related to that short side. So I just redrew this triangle out over here, and luckily we were given that short side. So this is going to be my longer leg because it's across from the 60 degree angle, and the longer leg is always radical 3 times the short leg. We don't really need to know the hypotenuse here because it's not part of your equation. So now that I know that the height is 2 radical 3 meters, I can substitute everything into that equation. So 1/2 times 2 radical 3 times 5 plus 7. Okay. So I'm going to start again by adding those 2 numbers together. Okay, I should have drawn it a little bit more. And so what these little lines were there for, I'll re-underline what I was talking about. So now we're multiplying these 3 values together. When you've got the radical involved in this multiplying, you're essentially going to multiply like the like parts together. So any number that's outside of a radical and any number that's underneath a radical. So I'm going to multiply the 1/2, the 2, and the 12. And I get 12. And then there's no other radical to multiply the radical 3 by, so I'm just going to tack that on and then put my units there. So that'd be 12 meters squared. We're still working on practicing those special right triangle rules, so all of our answers need to be exact with the radical in it, as opposed to the approximate value unless it specifically says to round. Okay. So here's another one. What we're going to do is start by what we did here. So I'm going to draw in the height. And what I did was I created a rectangle and a right triangle. So again, I drew in that right triangle over here. And so now I can figure out the sides that I need to. So I still need the height, and then I also need to figure out what this side is, because all I know right now is that this whole length is 14 centimeters, but I don't know what this base is. And so I need to figure out the relationship between this length and the entire piece so that I can figure out what this other base is. So in this problem, this was my 30-degree angle. I was given the hypotenuse. So that means that this is going to be the short leg. So that's always half of the hypotenuse. And that means that this side is going to be 5 radical 3. And so when I go to label this, I'm going to almost cross off that 14 for a second. So I know that my height is 5 centimeters. I know that this side now from here to here is 5 radical 3. And so that means if this whole length is 14 centimeters, that means that this leftover has to be 14 minus 5 radical 3. Kind of like what we did here, just backwards. So we did 7 minus 5 to get the 2. Now we had to find that, but we're still subtracting the part from the whole. So then I can go down here and label this other side as 14 minus 5 radical 3. Now the algebra here is going to be a little bit messy. It's not going to be the prettiest looking answer, but it's going to be a great way to practice like the distributive property, work with radicals, etc. So I've got everything I need and I can substitute in. So 1/2 times 5 times, and then I'll take one of the bases was 14, and then that bottom base was 14 minus 5 radical 3. So this was the top, this was the bottom. Okay, so now unlike up here, we were multiplying these 3 together. In this set of parentheses now, I'm adding and subtracting. This 5 radical 3 cannot be subtracted from this because they're not like terms. So when you're adding and subtracting radicals, you can only combine like terms, constants versus radicals. So I can only add together the 2 14s. Okay. And so what I would recommend then doing now is taking the multiplication in 2 steps. Because again, we've got this kind of compound radical here as opposed to just one value like we had with the 12 and the 7/16 here. So I'm going to start by multiplying the 1/2 and the 5 together. And then we will do the distributive property. So we're taking 2.5 times that and 2.5 times that. So when I take 2.5 times 28, I get 70. And then 2.5 times 5 would be 12.5 times the square root of 3. So you don't multiply the 2.5 underneath the radical, only on its like part. And then my units would be centimeters squared. This problem is pretty much worst case scenario. This is probably the toughest kind of problem you'd ever have when doing area of a trapezoid, or a kite or a rhombus or anything like that, when you've got like the subtraction with the radicals, etc. Okay. All right, so now we're going to look at rhombuses and kites, and these two are together because they have the same formula. So we're going to review some of the properties so that we can use those to help us figure out these areas. So the formula for the area of a kite and a rhombus is 1/2 times the first diagonal times the second diagonal. So we're multiplying those 3 values together. All right, so a couple things to remember about rhombuses. All 4 sides are congruent. And then the diagonals are not necessarily congruent, but they do bisect each other. So that means that each half of one diagonal they'll be the same, and then same with this other diagonal. And then they also intersect at a right angle. So we could still be seeing special right triangles, Pythagorean theorem involved in these problems. And then with a kite, the shorter diagonal is always bisected by the longer one. And then they also intersect at a right angle. All right, so here we're looking at a rhombus. I just like to organize what I can over here. So for both of these, all you need to know are the lengths of the diagonals. The side lengths may be used if you need to do the Pythagorean theorem, but you don't need to know them in order to find the area. So what we know here, and this is pointing to this little piece right here. And so if this part's 3, that means that this part's also going to be 3, right? Because diagonals bisect each other. So one of the diagonals is going to be 6 feet. And then if this is 5, this is also 5. So the diagonal is going to be 10 feet. Now I've got the 2 diagonals, I'm ready to find my area. So the area is going to be 1/2 times 6 times 10. And then we are off to the races. So we're going to get 30 feet squared. Okay. All right, this next one we know we're looking at a kite because the sides are not all congruent. And luckily here, pretty much everything's given to me. I just need to add a couple things together. So one of the diagonals, we'll do the shorter one first. 10 plus 10 is 20. And then the longer one, 10 plus 20 is 30. So when I go to find the area, it's just going to be 1/2 times 20 times 30. Now it's important to remember too, you're not distributing the 1/2 to both of these. So you're not doing like 10 times 15. That would be if it was 1/2 times 20 plus 30. But we're just multiplying these all together, which is going to be 300 meters squared. All right, so this wasn't originally here. So in this next example, we are looking at a rhombus, and we know that one of the diagonals is 10 inches, but we do not know what the other one is. So we need to figure that out. And so if it's not drawn in, definitely start by drawing it in. And then we have to remember that they intersect at a right angle. So if we were given that this entire diagonal was 10 inches, that means that each part is 5 inches. So if I want to know the length of this diagonal, I can find this length by doing the Pythagorean theorem with this right triangle and then multiplying it by 2 to get the length of the whole thing. All right, so when I go to set up the Pythagorean theorem, right, remember it's a squared plus b squared equals c squared. C is always the hypotenuse. So 8 inches, that's going to be my hypotenuse. And then I'll just put my variable here, and then that would be 5 squared. So 64 minus 25 is 39. And then when I go to take the square root, there is not a perfect square that goes in to 39, so I'm just going to leave it as square root of 39. And so that is only this piece, though. So that means that this is also radical 39. So that second diagonal, if there's 2 of them, is going to be twice as big. So it's just like if you multiply 5 times 2. It's just, we're going to keep it as a radical. So my area is going to be 1/2 times each diagonal. And then remember, we'll multiply the like parts together. So we're just going to multiply the 1/2 times the 10 times the 2. So my final answer is going to be 10 radical 39 inches squared. Okay. And then our last example here, this one I kind of breathe a sigh of relief with as well, because it looks like I know all the lengths. So I'm not going to have to do Pythagorean theorem, don't have to use special right triangles to find any missing lengths. I can go ahead and just find the length of diagonals and then figure out the area. So the shorter diagonal is going to be 12 meters. The longer diagonal is going to be 15 meters. And so when I multiply those together, 1/2 times 12 times 15 is going to be 90 meters squared. All right, so your homework tonight again is posted on Canvas. It's 10.2 worksheet. Just come to Canvas conference or let me know if you have questions.